software for learning. You also have the backbone, VG, Toilet, Google, Rednet, Number 4, number 5, you look at the data organization. Okay. 1, 2, 3, 4. And study for theory of AI, and then also for skill. You have plotted about data set and data logger in Python or in Ipcv. So you also with the okay, by all of the topics and concepts, I already planned in the reverse lesson. Okay. Because the reverse service, okay, we don't have class, so maybe you forgot everything. So yeah, I give the question in the final examination related to those topics reverse for this learning. We have several minutes to plan something from here. Any question?
Teacher, can I ask that what is the word that above the non-linear in the first row in the layers?
Non-linear.
Yeah, and the word above it.
Background, dropout, pulling. I remember I only explained to you about background, dropout only, right? I only explained background, dropout for you only.
Maybe just
Yeah,
drop
no.
out. Maybe just drop out.
Drop out, I only background. Okay, nothing. I already share with you slide, pick up slide here. Yeah, this slide contains non-linear also, right? Normalization of normal. Then no. Let's talk about norm first. Okay. And then I go with code. Here. I already share with you this folder, right? letter A. Okay, covered it. Before we go to the gnome, let's see how data transformation arise here. Okay, example. For the S is equal to, let's talk about numpy of random. For the more random, for the more, let's talk about normal. Number 5 is not a mean. The entity number 3. Okay, and the sign right now here, let's talk about the n value. Let's say n equal to 1000 points. 1000 value for the volatile. And range S dot set. So you had 1000 points value, and then you can see if we now min f, that is min f dot min. STDF and then you can see here the mean right now is 4.9. It may not be related to the number 4 here. Okay, it estimate the mean. So we sample the normal distribution with meaning equal to 5. So now we estimate and then it's 4.9. Okay, and the STD 3 is equal to nearly to 3. Okay, that is estimation. And then the data transform right now. So if we have SB equal to S norm equal to S subtract for S dot mean and divide for S dot SCD, and then you print it again. Now we divide here with S norm. And now after we transform by this formula means that the F norm equal to S subtract from mu for divide for HTD. Okay, that moment. And then after that you have the we compute the mean and the HTD of the S after normalization. You can see right now the mean is What is the value? 0. And STD? That is 1. Okay, nearly is 1. So that is the idea of the. So the formula here, this kind of normalization will transform S into mean equal to 0 and STD equal to 1. Don't care about the before, okay? The mean and value. Okay. That is the idea of transformation. And what is the range of S norm? What is range of S norm? No. Almost of students think that. But fail. But fail, right? So you can see about normalization distribution, normal distribution. What is the property of normal distribution? Okay, we study about a little bit about mathematics, right? Normal distribution. And you can see here this figure. What is it? Meaning? And tell me. This figure is tell you. What is it meaning?
This meaning that's 68% in the range of -1.
What does it mean in the range of?
1 standard deviation.
Okay. Can you understand this meaning? This meaning is very important. The figure is important for you. Can you explain? What does it mean? 68%.
68% in the range.
What does it mean? What does it mean?
I mean this one standard deviation. Equal.
When we sample.
When we sample, so what?
So 68% is like to the range of -1 to 1.
Yeah, thank you. No, not my 1. No. From which law?
Mean -1 standard deviation.
Here is mean subtract from STD, we call sigmoid. Look at the ball, please. The person in the corner. The person in the corner, can you explain for me what does it mean? Can you explain what does it mean? Tell me about what is range of density. What does it mean? 68, 95, 99.7. What does it mean? Look at me. You don't know why don't you explain or why you cannot explain the meaning? Why? Yes, I asked you about the explain for me about the meaning of 68, 95 and so on. Meaning, what number? What does it mean? Can you? Do you know what? No. Here this figure and meaning this figure is intellectual in this course. In this việc nghĩ rằng là môn này nó chỉ nó giải thế này. I teach you, and if I don't teach you, and then maybe you go, you plan. Dr. said, okay, don't tell me anything about it. Okay, here, come back to mathematics study. In which course?
Probability.
Probability. This course, and why? When you can. Because arms and further, when you study that course, you also focus on your laptop only. It's right. And then come here, the background here, and then you cannot explain. And you hold that, okay? You go into industry and you get the salary is high. Again, okay, you explain it correctly. When we sample distribution, for the book, 1,000 points. then 68% of that point come from this zone. This zone may not minus 1 to 1. Mean subtract for ATD, mean plus ATD. For example, mean equal to 0, ATD to 1, actually that is from minus 1 to 1. Okay? But if mean and different, ATD is different, and then the zone is different. But only 68%. And what do I mean? If we open the radius from mean subtract to ATD, means plus to ATD, it covers 95% of number. 1,000 we hold that, 1 million for we have got, okay, 95, okay, must be a lot number, okay, but we generate it only 10 points, don't hold that, okay. The probability in statistics is true for large number, okay, not only for the only small number. So that's why when you read a lot number, and then it's nearly, and here minus 3 entity and minus plus 3 entity, it covers nearly all. So when I ask you about the range, okay, that is almost a few just minus 1, okay, no, different. Okay, that is the meaning of the normalization, the transformation here. But the question is, why we need transformation? Why? Why we need? Look at the ball, the vanishing gradient, the opening. And then slide, you can see. For the ball, actually, for the ball, if you use sigmoid, very important, if you use sigmoid long linear, right? Can you see the rest? And the blue color, what do you mean? Right, blue, what do you mean? The blue curve we know that is symbol function. When input comes from minus infinity to positive infinity, and then its output is from minus 1, from 0 to 1. That is the blue curve table. But what is the red spot, the red line? Derivative. Derivative is the last derivative around. You don't know, right? But actually you can approximate less than 20, 0 or 21, 25. Right? Less than, right? It means that it's long or it's small. It's very small. Even that is last only at 0 here. And then if the input to the function here, what happens outside of this medicine? What is the derivative? Almost 0. Almost not 0, but almost okay. It is 0. And what happened? Here, backward. To compute radius, you have to multiply many local derivatives, right? And if for example, if the forward pass through small and backward pass, you must multiply this volume. For example here, very small volume 0, 0, 1, multiply. So for backward path, you multiply the derivative like that and here 0. The total is scaling 100 times. Okay, to divide to 100 only small. So whatever if you have, you pass through this level, you pass through a lot of nodes and just sum of nodes here only 0.001 or so on, right? And then how about that? How big is that? 0. And what do we call that concept? Vanishing gradient. Okay? But vanishing gradient we call here, not here, delta W. And why would it equal to 0? What happened? I cannot learn. Why I cannot learn? Because the history of that, half of that. Here is alpha is
learning rate.
And here is running. So whatever if here is 0, you look for me about 1 billion times or whatever, and then it's still okay, W equal to W or improve very small. Okay, so that's why even that If that you don't use the sigmoid or maybe time, okay, and also you need to normalize. Okay, sigmoid time. Even use radial also, because you make the radial is thick. And one more reason you need to the scale to the small zone. Not only vanishing green, but also how to store, how to set the memory of model. How to set. For example, if you pick up the backbone, you can see only backbone you have one more over there. Number of parameters here is 1443 million number of what? Of parameters. Mean that how many number this parameter here? For the okay, ascension 29 or 10⁹ million. Mean that multiply what? Okay. That is the million number. And then million. And then how big? How much memory to store this only? How to? What number how many byte? Using box, what how many byte? Maybe 64, maybe 32, okay? And normally by default how many? 32 bit. Okay, by default, right? Let's do how many byte? 4 byte. So you multiply here 4. Very simple. Then you copy memory, and you want to set the memory. Okay, a lot of multiplication. Okay, this might be run faster. You also set memory, right? So off, right? How to? You have to use half lot. Here full lot. Half lot how many bit? 60 bit. 60 bit means that how many? So you can see you set a half of memory only. But in order to use the half lot, the most important if the data, the value or feature is the RAM. Is the RAM, right? You must use large number of bits. Do you believe so? Okay, for example, for integer, for example, can you store integer in 1 byte? 1000 in 1 byte. The value is equal to 1000. Can you store it in only 1 byte? Impossible. Why? For character, the largest is only 255. Okay, so you cannot store it for it. Okay, so in order to the large output need the more bit to store. So that's why how to you scan, right? The range is smaller by normalization, and then you still smaller bit. Okay. So a lot of all the reason look too important, right? Okay, only. Is it clear? That is normalization. But the question here is how to perform normalization. You do nothing. You can estimate the mean divide for HD. You do. But if you do like that, the mean HD must be estimated for the whole training set. Okay. For example, if you can see, for example, if you use, for example, MNIST or C5 or any, okay, you can see you use 3 numbers. Some people don't know how to get number. And actually, from training set a lot, a million, they estimate the value mean HD for 3 channels. Alright? And then they get 3 values they supply to you. And then you should normalize by that. So that for mean divide for HD. It's simple. Okay, you can see in front of network, usually you have to do like that. or at least simple, you just scale from 0 to 1. Okay, alright. Divide by 255, 0 to 1. Okay. Okay, but question is how to perform bed norm. Because the network is you pass through network only one path. Okay, only one path. You can estimate mean sure, STD sure, but it's not the mean and STD of the whole data. Okay, so that's why. Okay, how to? They have to do that. That is the first formula for this. They have to restore the data. Okay, restore the data. Okay, after knowledge, restore the input like that. Here, the output of panel is just restore using the normalized data. You restore by another parameter we call gamma and beta. Here is two parameters here is learnable. Okay. So that's why the background is just the path through the network. They estimate mu and sigma. Okay, mu and sigma, and then they compute mu sigma. They compute the SH. They use how to restore the data. And so they learn it also. Okay, that is the one. Why they learn? Because they don't know how, because the mean and here is estimate only for what? For part data, not only the whole data, so they have to restore by learnable parameter during training. Okay, that is the method. And for example here, I ask you for example in final, if I pick up this, I ask you about what? Here, set input, set output, number of learnable parameters, and reset the field you tell me about. Okay. So how can we? You can compute. You can determine the set of the set in not change. Okay. Set maybe the set of input is just like that. On n what s will c, right? That is the channel bus. And input and output is the same. Okay. The set you can be about the same. Learnable parameter can tell me it's learn what? This. Okay. Output. So actually you have to practice in class. Here. In class here, for the method also. Based on 2D, you can see twice long. U4G.
cái ý tưởng là cơ trước này là còn sót cái là thầy thì muốn dạy cố định why bây giờ cái đó thì cuối cùng thầy mình cũng lên trước và lên trước
Okay, look at the ball. In order to answer, first of all, the shape of input output, you can believe on theory. You read the slide, read book, and then you believe, and then you answer. Okay, that is method one. Method two, how to do? You process by using A4, TensorFlow or Keras, right? You create object, binôme, and you create, you assign that with random data, right? Any right, you pass through and then you get y and you bring out set. Okay, that is method. What do you want? Big which method? I think at least you have to do that. Because you practice not only the knowledge but the skill. The skill you have to practice. So now, here it comes. Okay, you answer me. For the ball, get nom the what? Get ways. That is return your theorem. And at least you have to know type of them. At least, right? Okay, length of them. 4, right? And then what do I mean 4? And then you can see param for B in range what? B dot, yes. Dot set S Y S. Do you know Y4? Y4 value. Y4 and it is A, Y is A. A because the channel right now B is. Okay, so based on it compute mean and value, okay, on N, W, S and W. Okay, it looks like that. How to estimate the mean inside of based on S dot mean. Okay, for example here, acid equal to what? To 0, 1 and channel log means 0, 1 and 2. Okay? And that is the numpy. So that's why you can see reduce mean. Acid or beam, okay, before. Okay, each estimate like that, mu and sigma also the same, but the sigma radial mean reduce ATD, right? So mu dot set you can see that is AC. Okay, so if we not it compute the mean on acid 0, 1, 2, we not the S and W, only the C, okay, remaining. So only the C, so A. A like that. But question is why for value? Why it learn for? Learn for. Mu sigma the rig also here you can see a little bit different. Gamma, Bedmin, Bedmin, and what? The Va, the Ipcv, and it recover min in here formula. So you can see in graph waveform because you have moving bar, moving what? Moving min, and then what? Then and gamma, you can see gamma and beta. You know gamma and beta only, right? Gamma and beta, and also moving min, moving what? Moving what? That is 4. Okay, that is in the so that's why you have 4. So okay, I just tell you about what I mean background, and I tell you about how when I are doing in final exam or in exercise, I have to cover that. For each of those, you have to tell me about what is number of parameters, restricted field, etc. or that is. And then 1 minute. Okay. So the best way to study is risk line, risk document, and also
Practice.
to get information. And so that is the best way. Now, okay, any question about that? I remember only that background drop out and also pulling only, right? And then and concat also, right? Yes, in concat, right? Furthermore, concat also, right? They don't know what. Okay. Furthermore, if you have not like that, that is F, that is F1, that is F2, that is Y, furthermore like that. And here you can see N1, F1, W1, C1. So here we come aggregate. Then now aggregation right now is just element 1. Here not here right now here element 1. Element 1. Okay. So calculate in order to subtract the F or the element 1, subtract what is the constraint? Or conditional constraint. In order to ask element 1, what is constraint right now? C1 equal to C2. N first. N1 equal to N2. S1 equal to S2. W1 equal to W2. And C1 equal to C2. So that is also equal to N3. Okay, that is. And that's element 1. Another concept here we have also we can see when you draw you see raw C. C what do you mean contrast? Contrastiness. So here for element So for contrast, see what you want to transform. Contrast thì đã được mọi người gọi là channel contrast. Could contrast on channel. So what is the here? Here is also N1 equal to N2. F1 equal to F2. W1 equal to W. And C3 equal to C1 plus C2. We can test it. So you can see in network, you see a lot of the like okay, a lot like so okay, I did already here. Any question more about it? Skill now related to making program. And let's show you on the theory only, right? But in order to create network, to perform training and so on, you have to perform login data. For each bus, you forward, you backward, you update, right, and so on, right? So in that you perform the data. You have to, by on that here, data set, and the data set is loaded. Easily depend on the framework. For Kira, you have to use API for Kira to define. For Backlog, you also use API from Backlog to define the data set. So you have to process it related to skill, only skill, right? You say what I mean? Where is another? Where is it we call it when you train the network, you must say the log. Okay, you see ladder. Or you make, if you are working in a row, you have to share the training diagram for all of them. So the best way you have to use the system, the industry standard. Look like right now, you can use our Ansible or Ansible way there. To catch, to practice you, okay, during training, you upload the parameter, okay, log and so on, and this draw graph for you only, right? You have to practice. All related to all of skill. Okay. You say what I mean? For training, you have to practice using some industry standard are there to work, to catch your training process and share with all the person. Any question more?
Did in any lecture this we touch in the 3D convolution?
Really, because you understand that 2D and then you infer to 1D. The difference here is simple. For 1D, usually for 6-bit version or test version, because you have on 3, okay? So only here only time. So you have only one to scan the kernel is only left to right, okay, all time. So 1D. So 1D the kernel only one
point.
Okay? No 1 point. The kernel size only 3 minutes, 3, right? 3 volume on this zone. Yeah. In 2D, you kernel just for X and Y, right?
Square.
Okay? No, inside the block also, the channel also, right? By default it's channel also. And so that's why you have to move on the surface, right? That is 2D. You can see look like the kernel in 2D like that. If you move around the image, okay? So that's why it is 2D. But if you rotate the video, okay? So that's why you have the 3D. You can catch frame in frame and frame. You have a volume. Okay, so you have a W and also D depth. The depth is usually you can catch the single frame, frame. So your kernel by that time is 3D. That is volume also. The small volume might be 3 by 3 by 3. And then you move around inside of that. Okay, that is 3D. If you have for the boy another, let's talk about for the boy multi-dimension signal for the boy in radar, okay, signal. That is in the signal usually related to the faculty of the engineer, faculty of civil engineering, and then you have the multiple dimension. So that's why you have to have multiple dimension, not three. Any question more?
It's about the sliding dimension, not about the kernel size. The difference between conformity and 3D is about the sliding dimension.
Sliding dimension.
Not about
By default, you have the object channel. By default. For example, when we're talking about 2D dimension, what is the shape of the kernel? What is the shape of kernel?
any. Because
What is the shape? Kind of any. Not only size, shape is that, for example, shape là that. Only we call shape. The value S, W, C, any. But the shape must be 40. I guess you are shape here. When talking about shape, what do I mean?
okay.
The shape in 2D dimension. In convolution 2D, look at the ball. Some people I don't think you can do that. I'm about shape. Shape is not to get a shape. Shape it must be 40 for 2D convolution. Okay. So the kernel is how many shape? How many dimensions? 2D only S and W.
No, sometimes can.
No, not sometimes. Not sometimes. Always. The kernel must be 3D. But you just moving on only S and W, right? And but the kernel will depend on the kernel input. Okay? You see what I mean?
When we put many,
Look at the ball now.
many kernel.
So okay, why you can answer me? Because for me, I had to read. So I research, so I read book and read document and also practice, right? And I had information that I give you, right? And for you, or most of you, slide maybe no. And sometimes lock off, right? So random knowledge. You need not to practice, and then you answer me, impossible. So that's why, okay, I tell you the method for study, not only knowledge. Here, I demo here is just the method for study, for the book. The code is there, right? I just change here. Now convolution in 2D contain in by top, in channel, out channel. Okay? Out channel means the number of filter. But in period only out channel. No in channel, right? So for example here out channel right now here I use for example here 64 channel. Kernel size 3 by 3. Array like this. Okay, or like this. Strike equal to 1. That is equal to, let's talk about now, equal to shape. Okay, by default. GBR equal to 2 by default, right? By default that is 2, right? So I write here for you also. And then you can see. And right here you don't know what does it mean 64, right? and 3 in 1, right? How do you know? Reach document here, and then you can see the parameter first here is number of filter with others, number of filter kernel size, strike equal to 1, value equal to valid, on runner same. 0 by where? Here, equal to 2 by default, right? So okay, right now, to bring the same input and output, you can see what happened. You can see input here sitting minute outside, cannot change. Valid equal to same, so y input is S and W equal to 32 and output will be the same. And input is 3S channel, but output is 64 because you have 64 filter. I only give the last to you only, right? For now. And if you want to change here equal to valid, it's smaller. Why smaller? Half many, so you can see here, remove on left, remove on right, top button 1, you will put 30. Okay? Now, next, you can weigh layout equal to, let's talk about conclusion dot, get what? Get weight. At least you have to see study what does it mean. No, here is con. And copy and also have to change it, right? Here, this. So what is the length of them? 2. And what if I use here is 4 equal to 1 because there is no bias. Okay, so here is 2 again. Now, for the whole WB equal to WB, right? So bring W dot set B dot set. Okay, can you tell me about why B equal to 64? Because you have 64 filter. I mean that is 64 convolution. So each convolution has one value. So totally you have 64. Can you tell me why about that you have here?
A channel equal the channel of the image.
So how many filters right now? 64 filter. So 64 filter here you have here 64. And for each filter you have y 3 by 3 by 8. 3 by 3 means not because you here is size 3 by 3. Y 8.
Equal to the
The
channel.
in channel is equal to 8. So the number of channel in kernel must be 8. So the only one of you fail. I had a lot of questions in final. During lecture I also tell you about like that. Or most of you failed that question. I don't know. Okay. The kernel only the 3 by 3. Okay, here 3. But this is the volume because by default it has C channel equal to the C channel of feature mapping. S has A channel. Now another furthermore S to change here is S equal how many channel right now? Furthermore, let's say about 256. Okay, so you can see. Okay. In my slide also it plan like that. You can read my slide, right? In convolution it plan the same. Right? Why I did the same? Because when I look up into the internal of Kira and backup and then also slide in Fury and then I edit that slide. Okay. So another I hope that okay net okay because you failed so that's why I have to remove for you more. And it's very unfortunate separable. Okay, separable filter. Because separable filter you can see in Kira, you can see Kira dot separable. convolution tree, okay, and lazy. You can see okay, and then for example here I change here like that, and I do the same. Right, it's short. And can tell me why it's 3 right now? Okay, why 3? And then for example here you can see you have way inseparable, ways in way off. No, in way in 4y, in deep y. For y and way off. Primitive or what? W D S this one. Why? Here, can you explain for me about this also, right? So that I asked you about all kind of variation of conclusion. So that is a proper on space, we call it y. Suppose on pole 1 the conclusion 1 by 1. So you can conclusion 1 by 1 with a 64, so 64 here. And for that y you can see this here to 1. Here 3 56. If not, you have 56 channel. You can think that you use 56 channel filter. Each filter only 1 channel. You understand what I mean? The input here you have 56 channel. Okay? So right now in that y set problem is that you use 56 filter. Each filter only 1 channel. Okay, otherwise number filter is little more like that. Okay, no way out for it. And then you can see next you have to use phone y without only normal conclusion, but side equal to 1 by 1. Normal conclusion 1. And so you have 34, and here you have here of it. Sorry, different. The number you count number of parameters. You can search more, right? So that's why I think all of
the result of the conclusion to be with the separable conclusion to be different.
No, different. Well, okay, the what is separable conclusion? Why? Because by default, for example, 2002, 2012 ALET, 2003, okay, ZNet, 2014 VGNet, okay, 2015 RedNet, right? So until the different time, until from 2012 until 2015, they use by default the traditional conclusion tree. But one of the advantage of conclusion tree is what? What is the advantage of tree? Can you tell me?
Square.
The number of parameters is so the number of ways or learnable is too long. Why too long? Because you have what? You have how many ways? Here. You have the 3 by 3 but the number of channel must be the same as number of channel of input. So easy. You can count number here. Can you count number of number here? You can see one number here. Right there and here. Can you bring out the number of side? Equal to what? B dot sine that is 2 number. In Bertolli number, but here I think it's 2 number. You can see only how many filter right now? 54, 3 by 3. But the number of parameter here is equal to 4 to 2. Number of parameter like this. Okay, and then you can copy the same with that. Number of parameter equal to like this. Okay, very small compared to what, right? Very small, right? So that's why they improve by mobile net, but by exception also the efficiency. Okay, that is why they have to improve. Because the number of learnable becomes large, you need larger to train it, and it converges slowly. Okay, so that's why that is so that's why I can hold that input and input the same and output the same. No. Okay, different. Anymore. That is all right. Now just review, right? Just review. Now. And I think that is you have to analyze for me as many as possible for backbone. Because we don't have time to explain. Okay? And it is very simple. You log retrain and then you have to look like in here. Log retrain, import, log retrain and then forward and get feature and then okay, get feature at any point and then show the shape and then visualize and so on, right? That is the best way to practice. Best way to practice. Any question more? No, so now okay, we go to the lecture about detection and segmentation. Before I emphasize that on the logic is the basis for deep learning, so will be final exam soon. Okay. Now, we talk about detection and segmentation. And what does mean detection? Here is detection. For example, here you draw the box without a rectangle, and you also give the name of the class of the object inside the box. So we call the detection. So detection you have two parts inside. Detection that equal to part inside. Part one is local deviation. Mean that you infer body more. And top two that is classification. You infer the class of top. And what I mean segmentation? The segmentation you had a picture. You also give the mark around track inside of the box. We call instant segmentation. Instant, what I mean, if you have two persons, it mark different, okay, inside. Each level here, the human, which human, different level, we call instant. If the merge, okay, here and the person here the same, we call segmentation. So you have segmentation, you have instant segmentation. Or visual. You have two, only the segmentation. Ngữ nghĩa cá thể, now here instant because we give the mark for each person inside. Mean that two persons to different level, three person and person in different level, we call instant. If with the same level, we call semantic only. Okay, that is the meaning of semantic. So segmentation is just classification of this one. Okay, there you go. Now that is concept, right? Now, until now, I give you the SOTA of segmentation instant and also detection, that is 0 versus A. That is the SOTA of state of the art, right? Of the detection. And there are three levels of using three levels. Level 1. Level 2 and level 3. If you want. Level 1 means that in the universal way only trained with 80 level. You can see the set of like that. 80 level. If you want to detect or segment with the level the same or smaller or subset, you don't want to do anything, just use it. Okay? Level 1. Just use. Why? Maybe you only you can see here and just use it as info. And now level 2 means that you want to train the YOLO with your own dataset. Okay? With your own dataset, we call custom dataset. Yes. Custom dataset, right? And whatever, okay, whatever the dataset, and then that is level 2. And after train, and then you have to view it, look like that, okay, level 1. Now level 3, you just explore, you just study, you learn inside, and then you can review some component inside, or you capture the idea inside in another paper, another project, right? Okay, you understand. That's 3 more. You custom and understand. Level from 0 to 1, or 1 to 3. Now that's for level 1. For level 1, just you. Quite simple. Here I demo for you. How do you? Sure, first you have to install. Maybe just only this line. Only that one to install, right? No need here also. No need to install. Okay, now just one line to install. Next. No need because you have to API, you have to read document of the ultralattice. Now what do I mean ultralattice? Ultralattice is just the look like the GitHub or repo to contain the source code, okay, of the raw versionage. You can GitHub, you can see, you can go to the link here, GitHub, okay, and you search ultralattice and GitHub, and then you can go to this website. Now you just install and then just use there a lot of ways. Inference. You can infer the hyperlink, and then here conference you want a lot of object, but you want to filter out all of object. Let them this conference you remove. You keep only one. And you know so have some code for you to block and to remove the value. You can see here. It remove strictly. And if the raw also the code the zero also have your code to write for you. Okay, not you. Do not write anything, just call that function. Here you can reach the code for you. So you can see the code for drawing is longer compared to the code for editing. Okay? Just one line. So for you, just one line code.
What is conf again, please?
CONF, confident. Confident, what I mean, the idea here is when the detector locate and also class, but it also has somebody from 0, 1, that is represent for confident. For the 0 without or very small, it's very low confidence. Big 1 or very high, near to 1, that is very strong confidence, or very high confidence. Because sometimes you see the object, okay, it's far from you, but sometimes for human you see maybe that is a human, or maybe that is a car outside, right? So it depends on your confidence. And now the confidence represents the probability. It near to 1 is very high confidence, low, that is very low confidence. Right? So okay, you can ignore the result here. Sure, you have to Google the ultralattice with the result object, and then you can learn more. Put here is symbol for drawing. For you, level 1 symbol. If you want to here to put 3 ring or more, and then you just give a little blink. Give a little blink, and then you right. Give a blink. On internet you can try. You can try. And another, if you want to download and to detect another view, I give you the code here to download into the image and to put the image into the page, the model, and then get the result to draw. Okay? If you want to predict a folder, and you just hit the folder name. So I have to download Dyson Rider, and then I give the folder, and then it detects the card inside. Okay? And after that, I show some result for you. Here, some result. Okay, some result. Okay. Or if you want to predict for a part of this, a part of N, F, W, C. If you had a big data set, and then you have to define the set. Okay, I told you that how to define the set in PAE form. Here is method. In Github also have the concept of data set. And then you're going to define asset, and then you define transformer. Okay, you learn about that here. Just skill. It load rather than image. It has to transform. Transform not resign. You know resign in reverse just along center code. Okay, you got the center code. And two tensor not 0 to 1. Okay, scale 0 to 1. It is a timeline. And I define that's it. And now I just log for each a box inside. I delete the box and the raw object. Okay. If you want to do like that, you do that. Okay. Got it. So you can see level 1 is easier, no? Quite simple. I don't think that is difficult for any student because I think in high school, okay, they also can do the level 1. Now for level 2. Level 2 the training. Now you have to train. I give you about the training set. Furthermore, in order to train, you have to store overnight the data in the format of YOLO versioning. Okay, so we have concept of YOLO data format. How? Because here is image detection. So you have the folder of Coco renovated the idol from the report. Inside would have a folder from image and level. The folder image you have train 3 versions, train, vo, and test. And now in 2, but usually you have 3. Okay, the 3. And train, it contains image only. And then image. It's just any name. Okay. So the image right now here is the file JPEG, right? It has the one file, text file, contain level. The text file is in text format. Just here convert here is the text by the CNN would essentially TXT, right? Text. And you have to store in. You have to store in level. Okay. You store in level. And level right now you can see for detection. There are 1, 2, 3, 4, 5 values for each row. For detection only the 5. The first we call ID. The next we call the CF. The next we call CY. The next we call W. For each row. If you had image like that. If you had a fault like that. So center we not here. CF, CY. WS not here, W. Here is the format now. And you think here is, don't worry, you had a tool, a lot of tools in the internet, upload asset, and just the ROI, right? And then you export. YOLO version A is your. Don't worry about that. He just not your work. Trước here the labeling, trước the company, trước brand, some person to level. Here trước only nữa. We call the handbooking. Okay, don't worry about it. The format you understand. So for detection you have many rows. One row represents for one box. You have only row here from the image contains 8 objects inside. Right, from number 1 to 8 box inside. So So you can imagine the desert, the data level, right? Now to train. Before train, you have to have one concept called the metadata of the dataset. For example, here you can see that is exam file. Do you know exam?
Yes.
That is because exam file converts to dictionary file symbol. Okay, so you have to use exam file. Here, the path to data, the train location related to the path, test location related, evolve test related to the path. Name of class, you have 80 names right now here. 80 names from index from 0, right? Remember, always 0 in there. Here is the string. Very long because it is 80. So from 0 to here is 80 totally. And if the is not available, it also go from here. So you prepare only, then now you should train. So in now, the part for drawing, okay, labeling only, right? Okay, and when you if you tool, there are some tools which have the concept of global format. Global flow which can talk for you about the Euro S format. It export here. The same for you. Don't do anything. Now training. So first you have to install. This line is fine. If you don't want to have support. And now you have to download. That's it. For example, here in Google, you have to download, right? That's it. Organize into the folder. And now train. You need only one line to train. Two lines, but you can put train into here, right? Not train, just one line. So is there any advantage of CS carrier with other university? Or do you have any? If you just level 2, you don't have any advantage. Because code is just one line to train. For leveling is not the task of the engineer, right? Task of level, working. The you tool drawing, right? So don't do anything. Don't. You just train it, just one line for training. That is important. So it runs long time, right? Depends on your heartbeat, your set also, right? So you can see it takes a long time to train, depend on. But now I train for simple research here. For example, here I train for demo for road desert traffic light. I show it for you. Okay, or maybe another. Okay. It detects the traffic light and also label the traffic is red or green or blue, right? So right, and it can do one level. It can do one level, right? So you can see this train here, it covers around 30 volt. It takes around in T4 card. Google Colab, right? Google Colab Pro. It runs about 15 minutes to complete. After training, so you have a model. It says the best model for you, right? So now you just view it. Now you lock the model. Here the best model you can see. Because you train, you have the best model, you just lock the best model. And you read the same. You read the same, right? You can detect the UCM level 1. Now it's level 1. It detects level. The red line you can see red line, right? And it also what? Order. Here is red line. Here also red line. Here green line. You can see green. Green. Okay, now done. Not done for level 2. So you can see level 1 quite simple. Level 2 also quite simple, right? You just down the drawing, download data, and then just one line to train, and then log in and view, right? And if you don't want to deploy on the GPU card, like TensorFlow, TensorRT, and then you just on web, right? Just in Python you write by web backend, you write by example, it is also Python, and you can log model, predict, okay? You say what I mean? You build a web application, okay? It's simple. Thì your TensorFlow, right? And now what is it? Okay. I give you a chance, right? But actually the number, the part is just okay. Not it means not okay. Now I know the sum of things. Okay, now just working on development, on the testing, segmentation. Okay, and then I come here, come to me, and then I examine. So that's why actually I give you credit because you do something, but actually the number of line is quite small, right? You can see. Okay, I will go for you only for level 2. Now we go to level 3. But okay, level 3 now we no time because I give the next time. Okay, I block the course, the draw. Now go level 3. So level 3 level 1, level 2 is okay, easy, but level 3 you have to explore the model, and then you have to know how each structure, how to train it, right? What is log function, everything over there, right? Over there. Log function, training, everything, then you can see not easy. So I hope if you are studying computer science, if you have to go to level 3. Because level 1 you stop at level 2. You don't have any advantage compared to all the students, all the faculty, and all the universities. Okay? So you should move to level 2. Okay, I want to stop right now. Any question about it? Today is 5 minutes more. If you don't have any question, I summarize. I give you not only the knowledge, okay, the skill you have to practice for yourself, but I give you the method for study. Reading slide, reading document, and also practice to get the information. And also for you going level 3 also, I don't think because you know version A or somebody maybe in some other paper. No code or for you no document. Okay? If you fail during the line, right? Industry, you didn't learn in or industry. Maybe we show some project, no code, okay? Just only document. Or some with code, no document. How to? You have to understand level 3. So I give you the method. So you have to run the code, debug, and then try to explore everything, and then you know exactly what it is. So during the lab, you have to need first language, English, right? Net, Python. So programming language and also the natural language, okay, combine together to understand everything. That is method, no other choice. No, hope that okay, easy. No, hope that easy, but level 3 not easy. Okay, so you can see I net do it. I will show you how I do it. Okay, if you don't have question, I close right now.